Hello everyone. Good morning, good afternoon, good evening. Today we are going to learn VPC and its deployment scenarios. So what is a VPC? So VPC is a port channel through which we can attach a third device to two different switches, right? So in such a way that the third device sees that it's connected to logically one devices. So a VPC port channel enables a physical link to be connected to two different Nexus 7K or 5K series switches to appear as a single port channel to third device. So this is your basic logical topology where you have two different switches which is connected to to which is connected to a VPC domain, right, via port channel. And if you see the logical topology, this is switch 1, this is switch 2, and this is your VPC switch, right? So now what is the NXOS version and license requirement for the VPC? So VPC runs on Nexus 7K and 5K switches, and its NXOS version should be greater than 413, right? And it requires the base license for the Nexus 7K and 5K series model. Now, if you want to learn about the component of the VPC, so let's discuss one by one. What is the VPC peer device, VPC domain, VPC peer link, VPC peer keep alive, VPC member port, and a VPC VLAN. So what is a VPC peer device? VPC peer device comprises of two switches. They are a part of a single domain. So this is your VPC peer devices. They are a part of a single VPC domain, right? Now, what is a VPC domain? In a VPC domain, maximum two Nexus devices are used to form VPC domain, right? When we create a VPC domain, the virtual MAC address of these two VPC peer switch will be same. So VMAC of both peer switch will be same. Now, what is a VPC peer link? VPC peer link is a port channel between your VPC peer devices. Now, what is it used for? It is used to share the CFS protocol packet, control packet, right? And this link also carries a layer 2. It is a layer 2 trunk link for carrying a VPC VLAN. Layer 2 trunk link to carry VPC VLAN. So if you see in the diagram, this is your peer link. Now, what is the VPC peer keep alive link? This is a layer 3 link which is used to send a VPC keep alive message every second to prevent a dual active or a split brain scenarios. So what is this one? So VPC peer keep alive link is this one. This is your L3 link, right? Which is used to send a keep alive messages between these two peer switches to avoid the split brain or a dual active scenario. Split brain or dual active scenarios, right? Now, what is a VPC member port? Those port on which your edge devices are connected and they are a part of a particular VPC. So if we see in the diagram, this port and this port are a part of a single VPC. this member port and this member port are a part of VPC 20. Right? And what is a VPC VLAN? VPC VLAN are those VLANs, which are allowed on a VPC peer link, and they are configured on a VPC member port. So VLANs allowed on VPC peer link and member port. Now we will see, another topic. So we will see how, data loop avoidance is done on a VPC data plane. So if we talk about in the VPC, the loop is avoided at a data plane rather than control plane. So when a data traffic flows like, broadcast traffic or a known unicast, for that, those type of traffic, the loop is avoided, right? So as per Cisco design of VPC, all data should be forwarded locally and peer link should not be typically used for a data packet. So in ideal scenarios, we should not use a peer link for your data traffic. Rather, we can, send our traffic locally. Why? Because the peer link is used to synchronize the control plane information like MAC address, port state information, IGMP information between a peer switches. Now let's see how, data traffic, the loop is avoided. Let's suppose this server A, it's sending a broadcast packet or a known unicast packet. Right now, when it sends, let's suppose in a port channel, it chooses this link and it went here. Now, as soon as switch 1 receives this packet, the MAC address of this packet will be recorded. So let's suppose this MAC address is recorded here. Now, as soon as the MAC address is recorded, because the CFS is working between S1 and S2, the CFS will propagate this MAC address, and this MAC address will also, recorded here due to CFS protocol. Second thing, because CFS is also, share the information of this port state. So each VPC peer link will share its VPC member port state information. Now, because this is a broadcast packet, this will flow. It will go to S2, right? On S2 here also the MAC address A will be recorded of the source. Now, because this broadcast reaches here, and the nature of broadcast is that the switch will send this broadcast packet to every port. Now, before sending this broadcast packet to this Ethernet 1x2 port, it will see that the traffic is crossed the peer link. What it will see? It will see is this traffic crossed the peer link. Here the answer would be yes, right? Because this is a broadcast and it has already been crossed via S1. Is its VPC member port on peer device is up? So here, on S1 ETH 1x1, answer would be yes. So in both cases, the answer is yes. Now, the switch S2 will see that the broadcast packet or a known unicast packet has crossed the peer link, and the S1 member port is already up. So in that case, the switch S2 will not forward the broadcast packet down to its VPC member port, right? Now, only exception is that when a VPC member port goes down, right? So both VPC peers device will exchange the member port status and will program the VPC loop avoidance logic and thus the VPC, peer link will be used as a backup path. Okay, now here we will see, what is the VPC deployment scenario. So there are two type of VPC deployment scenarios. One is a single-sided VPC, right? So in a single-sided VPC, you have a VPC domain, right? And the access layer, you have your, access switch, right? You can have your load balancer. You can have your firewall. You can have your, servers, right, connected to it. So this is your, single-sided VPC. Now in single-sided VPC, in the Nexus box, if you have, M1 series line card, so in that case, you can have, a 16 active member port in a particular port channel. Member port in port channel. So if we say it, so if this is your Nexus box and this is having M1 card and this is also having M1 card, and this is this is your anything, I mean your server or anything, you can have a 8 link here, and you have a 8 link here, and all you can bundle it to have a 16 link, right? Now if you have F1 or F2 card, you have a 32 link to form a port channel, right? So 32 active member port, you can form 16 from one device and 16 from another device. Okay, if we talk about Nexus 5K, so 5K will have a 16 member port, 8 here and 8 here. Now in the dual-sided VPC, what we see that there will be one VPC domain here, and there will be a second VPC domain here, right? And the ID of those VPC domain will be different, and here we will form a back-to-back port channel, right? And they are a part of a VPC one. So in a double-sided VPC, there are two different VPC domain as shown in figure, and the port channel between these two domains are a part of a one port channel and a one VPC. Both two VPC domain must have a single, a different domain number, right? So this is your single-sided VPC. We have VPC domain name 10, and here we have a VPC domain number 20. So these two VPC domain will be different, and also VPC domain in the bottom used for active connectivity. So this is used for your active connectivity from endpoint device to access layer. Okay, and VPC domain at the top here is used for active FHRP in layer 2 or layer 3 boundary. Okay, so thank you for watching VPC terminology and deployment scenarios. Thank you very much. Take care. Bye bye.